Okay, so now let's look at a decomposition of a carbonate. So decomposition of a carbonate, we start with a metal carbonate and we add heat. If you remember from our prac with the test tube with the sidearm, we added heat that then went down the tube into the lime water, which we then used that to indicate that carbon dioxide was going off or being released. So metal carbonate decomposes into a metal oxide and carbon dioxide. So if we look at our decomposition of a carbonate sheet here, let's do the first one here. So the first one is calcium carbonate. So in order to be able to work out the decomposition of a carbonate with calcium carbonate, we need to first work out the chemical formula for calcium carbonate. Now we know calcium, it's on our periodic table, calcium here. So let's write a Ca for calcium, and it is in the 2+ column. It has a valency of 2+, so let's put a 2+ up there. Now to work out carbonate, we need to go to our common anions and common cations sheet. And we need to find carbonate, which is there, which is CO3, and it has a valency of 2-. So 1, 2, 3, 4 from the top, CO3, 2-. So we know that it has CO3 and 2-. Now what this tells us is this whole CO3 has a valency of 2-. We think of the carbonate in this case as being a whole element or a whole molecule. And then calcium 2+, carbonate 2-. We can swap and drop, but we know that 2 and 2 are equal. So our end formula is going to be CaCO3. Now that we know the end formula, we can do the decomposition of a carbonate. So CaCO3. Now this little triangle you might remember means heat, so that tells us we've added heat to calcium carbonate. We're going to get a metal oxide, I'm going to get carbon dioxide. So we know the formula for carbon dioxide. Let's put that over here. CO2. And the metal oxide is going to come from what's left over. Oxide meaning it's going to be one of these oxygens, and that's the metal there. So the metal left over is going to be CaO. Now, to check that this is now a balanced equation, we need to check that all the calciums, carbons and oxygens on this side equal the calciums, carbons and oxygens on this side. So let's just go Ca equals, C equals, O equals. And on this side we'll go Ca equals, C equals, O equals. So we have 1 calcium, we have 1 carbon, we have 3 oxygens. On this side we have 1 calcium, 1 carbon, and 1 plus 2 equals 3 oxygens, which tells us that this is now a balanced equation. Most of the time, in fact I can't think of a time when it wouldn't be the case, because we're just decomposing this element by the law of conservation of mass, this as it breaks down will have to be balanced with what's over here. So that might help you when you're looking at decomposition of a carbonate to remember how to balance that equation. It starts with 1 calcium, 1 carbon and 3 oxygens, and it breaks down into 1 calcium, 1 carbon and 3 oxygens. So that law of conservation of mass is maintained here because we're just splitting this one compound into two different compounds. We're not adding anything in here that we might need to balance on that side. We're just splitting that one into two separate compounds. Now on your sheet, decomposition of a carbonate at the top, the front page. We also have magnesium carbonate, lithium carbonate, potassium carbonate, and sodium carbonate. So I want you to have a go of those on your own. You can refer back to this video if you need help, but that should get you started on decomposition of a carbonate.